This is problem 63, and we want to think about the reverse reaction. So remember, amines can react with ketones and aldehydes to give you amines and enamines, and then alcohols can react with ketones and aldehydes to give you the corresponding acetals and hemiacetals and cyclic and non-cyclic and all that kind of weird stuff. So here we want to think backwards. Now, when you react this with H3O plus, you're basically adding, H2O. All right, you're adding 2 hydrogens somewhere in the molecule and 1 oxygen, and H plus just serves as the catalyst. Okay, so let's discuss the reaction of enamines and amines. So if we have this guy here, okay, a double bond, where you want to disconnect this molecule is right here. This carbon-nitrogen bond needs to be severed, okay? So what that's going to give you is, well, we're doing a hydrolysis, so I don't even need to think in a backwards sense. So if I add water and H plus to this, this is going to form the amine up above, okay? And you just add a hydrogen. Just remember, nitrogen always likes to have 3 bonds because it has an octet. And what do we do with the bottom portion? We take this, you ditch the double bond first of all. The carbon-carbon double bond is not drawn in the product. Instead, what we draw is a carbon-oxygen double bond, okay? Carbon-oxygen double bond. So these are going to be the major products that you form, okay? Here's your amine. You're adding a hydrogen here. Here's the ketone. You're adding an oxygen there. And then it's extremely subtle, but you're adding another hydrogen to this carbon. You see, over here, it has just 1 H, and over here it has 2. All right? So here's your H2O that you're adding, and that's done with acid catalysis. So this is an enamine. Okay? It comes from amines and ketones. Or aldehydes, but this is a ketone. So let's think about problem B. This is an imine, okay, imine. And let's draw that in yellow here. And I think in some ways it's easier to see here because the double bond stays, okay? So what do I mean by that? Well, we want to disconnect this connection here in the molecule, okay? And if we treat this with water in H plus catalysis, we're going to form the amine, okay, that comes from this fragment here, okay? So let's draw that out. We have a nitrogen. We have a methyl group. I'll write CH3 so we're not confused. And remember that nitrogen likes to have 3 bonds. So we're going to need to add H and H, okay? So that's your nitrogen, or the amine. And the other fragment, it's more easy to see in this case. We have the double bond. Instead of going to nitrogen now, it's going to be going to oxygen. Okay, so let me just highlight for you, where's the water, okay? So I'm adding water, one of the hydrogens, one of the hydrogens, one of the oxygens. That's where all the atoms are accounted for. And this is done with, of course, a catalyst. Okay, in part C, here we need C, D, and E are all called acetals. So remember, an acetal is when you have 2 kind of ether-looking things attached to the same carbon, and you can hydrolyze this guy with H3O plus or water and H plus catalyst to give you a ketone, and it depends if those are the same or not. But, you form alcohols, okay? So alcohols and ketones. So this is your template, all right? This is the template we want to follow. And so we want to look at this carbon right here. In part C, we know that that's going to come from, here's that carbon, a ketone, okay? That's the acetal carbon that I'm dotting. So it comes from cyclopentanone. And then what about my alcohol? Well, be careful when you consider your alcohol because this oxygen here is bonded with some carbons to this oxygen here. So what you're going to form here, instead of two different alcohols, is one diol, okay? So it's a diol. So yeah, watch out for that when you have cyclic systems, okay? Now, in part D, it might be really hard to think about this guy here, okay? Where in the world do we put our ketone? Where's the alcohol? I mean, it's just like one kind of crazy looking thing, okay? So when you look at this molecule, let me sketch it out, and we'll kind of do eraser chemistry here, okay? So let me see, I'll try to reduce the size of my eraser. Okay, so here's the starting molecule, okay? So what you want to do is, again, let's look up here at our template. You're basically going to be disconnecting one of the OR bonds, okay, and disconnecting another OR bond. So using my eraser, I'm going to disconnect this OR, okay, and I'm going to add an H. I'm going to disconnect, sorry about the flipping back and forth here. I'm going to disconnect this OR bond, and I'm going to add an H, okay? So that's the first step, okay? You're removing this, and then you're adding those little hydrogens, okay? Those little hydrogens to the oxygens, okay? Now, what you need to do is follow what I've been doing previously, is take this purple dotted, carbon, and you want to change that into a carbonyl, a carbon-oxygen pi bond, okay? And we're not violating anything. This carbon right here has 4 bonds, okay? It has 4 bonds, so that's good to go. In part E, we have, once again, we want to hone in on that acetal carbon. We want to remove this OR group and add a H to the oxygen, so HOCH3, okay? So molecule D, by the way, in part D, that's the only thing that's being formed. There's no other anything, okay? It's all kind of connected. So, but this one, things are different, okay? So now you want to remove this oxygen, okay, which is bonded to a bunch of carbons here, okay? And you want to add hydrogen to that oxygen, okay? Now, the carbons, okay, I kind of dotted them here so you could follow along. Okay, all the carbons are there, but remember that this carbon here in the darker, more bolded, bigger purple dot is going to be the acetyl carbon, so that's going to be your ketone. So I'm going to doubly bond that to an oxygen, okay? So that looks like it's connected a little bit, so I'm going to draw it off to the side here so we don't get confused. Okay, so that's one molecule, and then HOCH3. So in this case, the methyl alcohol is separated from the molecule, but in this case here, this alcohol is combined or connected. Okay, so that's how you do problem 63. It can be quite complicated.